Ooh, what's up, people? How we doing? How we doing? Today's another stream day. We're going to be streaming. Let me know if there's any like weird errors, weird buffers, weird shit, stuff. I'm sorry. Okay, it looks kind of laggy, yo. All right, let me go on my screen face or whatever. Ooh, what is going on? Dang, this stream is tripping. Hold up. Y'all are showing the wrong screen. All right, let's get this display right, because come on now. Display 1. That's my Discord. Come on now. There you go. All right. There you go. That's how the stuff's supposed to be. All right. Cool. Let me close Discord. Told you I'd make it. Hey, I'm glad you made it. I'm glad you made it. All right. I'm gonna finish drinking this water, and then we'll consider getting back into work. We'll see. Oh, so last stream we started developing a how do I say this? So we're working on the Visionaire Cipher, right? A cipher that basically uses. You know what? Let's do a little recap, boys. Let's do a little recap. It's classroom time. All right, we're gonna teach you some stuff. All right, where is Visionaire? That's reverse. Visionaire. Awesome. So let me zoom in. Can I zoom in onto this? All right, it's kind of trifling right now. Let me whip out my GitHub instead, because GitHub is... Okay, let me check something. Yeah, I don't know why the stream's acting so weird. Maybe I should stop recording. Let me see what happens when I stop recording. And I just stream. Maybe that will help. Stream. Okay, so yeah, there's not much we can do about that. I'm in school right now, so you're muted for... Oh, that's cool. I'll let you know. Cool. All right. So right now, okay, actually, I keep forgetting what my original intention to do is, because I have the Obsidian for this, but it might be kind of hard for you guys to read, and it looks very pretty on the GitHub. And I will also drop the link to this whole thing in the description, because, you know, to make it a little bit easier for y'all. All right, let me copy this. All right, there you go. So this is the all-powerful, very beautiful GitHub page for this project so far, you know, the Codex project. If you go to roadmap, sorry, cool. So if you go to roadmap and then Visionaire Cipher, which is the one we're working on, this is basically the entire quote-unquote roadmap on what we're doing and how it's going to work and all that other fun stuff, right? So we are working on the Vigenere Cipher, and it basically relies on the index of each letter within the key to encrypt a certain set of text, right? So we're starting with this, whoa, come on now. All right, cool. So we start with this chart, right? So each letter, A through Z, has an index. So A has an index of 0, B has an index of 1, C has an index of 2, all the way to Z having an index of 25. All right. Now, we will have our encryption key, right? In our key, we're literally going to make our key the word key, K-E-Y. And there, you know, each letter within the key has an index, right? So K, right here, has an index of 10, E has an index of 4, and Y has an index of 24, right? So when we have our plain text, we're going to call our plain text encrypt because this is what we're encrypting, right? Again, each letter has an index, right? So E's index is 4, N index is 13, C's index is 2, etc. So when we come to the point where we're going to encrypt this text, we have our plain text, and we have the indexes for each letter in the plain text, right? So E has an index of 4, N has an index of 13, etc. Now we have our key, and we're just basically going to take our key, and then for each letter within the key, or for each index within that key, we're going to be adding that index to these indexes, right? So again, our key has index of 10, 4, 24. So we're just adding 10, 4, 24, 10, 4, 24, 10, all the way down until we have added it to the indexes of our plain text. Then we have these new indexes from the values we added together. And then this is our ciphertext from these new indexes that we got. So the index of 14 is O, right? So the index 14 right here has the letter O, which would be O. And if you follow that process, this would be the encrypted word, oribisand, right? Um, and to reverse this, you just do the opposite, right? You have your ciphertext, then we get the indexes of each letter, then we just subtract the key, get these new indexes, and then match each index to the letter. That's how the Vigenere Cipher works, as a whole, in general, etc., right? Cool. Let me, I guess, zoom out. So, I don't need this anymore. Alright, I'll drop the link to the repo. And we pinned it in there. Cool. Sweet. Alright. It's fine. I just started streaming. I drank like half of my water already. Kind of annoying, but it's alright. So right now we have a working version of the encryption and decryption processes. So let's go ahead and cd into documents, code, and codex. What? Oh, Python codex. There you go. So if we do a Python 3 main.py, we have the codex, and we have Caesar Cipher functionality and the Visionaire functionality. I misspelled Visionaire right here, so I'm going to have to fix that. But now let's say we want to encrypt the Visionaire. We would do the tag V for Visionaire. And then to encrypt something, we could do, let's say, encrypt hello. We'll use tag K as a key of, I don't know, hi. And that should be it, I think. Attribute error. Okay, so something isn't working. Oh, I forgot. Whoops. We need to do a tag T for the text. Whoops. There you go. So count for this. But now it does work, right? So the tag T, which is for the text, which is hello. We can also input files as well using tag F, I think. Oh, so it's tag I for the input file, and then tag O for an output file. Cool. So that's the encrypted text, right? And then we could decrypt it, and that functionality does work, right? So what we're doing now is we're incorporating something very specific to Visionaire, and it does work within some sort of other ciphers, but this process alone is specific to the Visionaire, where you can figure out the key of a, or I guess you could really decrypt a encrypted piece of Visionaire if you don't know the key. Through this, you would basically have to know the length of the key, but with Python, we can just iterate through several lengths of keys, right? And by using letter frequencies, which is basically like how common each letter is, you can basically get the key and decrypt the text. So we found a program that could help us do that, and I was having a lot of trouble trying to figuring out how it works, because I thought it didn't work. But it turns out it does work. This whole time, it works. So if we cd into resources, and I think there's a cd Visionary breaker. Yeah, so our unknown key, this is our file right here. Turns out this does work. You just need to incorporate a long enough string for it to work. So let's go to here. All right, so I put some random stuff in here. Hold up, let me go on my face. That's funny as heck. Yeah, I just wrote a bunch of random stuff so that way I could get this working. If you guys saw what I wrote, that would be funny as heck. All right, so let's go ahead and actually encrypt something. So let's make a file for, all right, we'll make a file in here. New file. We'll literally just call this proof of concept.txt. Awesome. So we're in the proof of concept.txt, and we're literally just going to, oh, actually, no, I need to move this into the area of the main code so I can, yeah, move it. Sweet. All right. So we have our proof of concept.txt. This is what we're going to code, right? So let's take random word. Okay, I'm literally just going to go on Google and get like a lorem ipsum thing. Love the posters. Thank you. Yeah, there's quite a few cool posters. There's a custom Cosmodium poster I got over there, and then there's like some DedSec posters, and then Cosmodium posters. It's pretty sweet. So yeah. What are we doing? Lorem ipsum. Lorem ipsum. All right. I just need the largest lorem ipsum generator. Thank you. All right. We need what's 5? Oh, 5 paragraphs. Got you. 5 paragraphs generate. That's perfect. All right. So we'll go up to like here, right? So we just need words. By the way, full shout out to Adanu on the Discord server for telling me how this actually worked, how the code worked. All right, perfect. All right, this needs to be one line. Oh, perfect. All right. So we have this giant line, right? Let's encrypt this. And we should get lorem ipsum dolor setamet, right? So we're going to see the out of here and see the out of here as well. I don't know why I just didn't do it at the same time. So we'll do the Python 3 main.py. And then the TAC-v. And our input file is going to be proof of concept.txt. I don't know if I should actually have this thing in it. I'm just going to do it. And then we're going to do, oh, I need to do an encrypt. So TAC-eve to encrypt, TAC-I, and then we're going to need the TAC-k. So we'll just do like hello as our key. And oh, sweet, I'm unmuted. Gotcha. Bet. No value was given to your argument. What did I forget? All right, so clearly my code needs some more work. However, so main.tac-v, which is Visionaire Cipher, TAC-e is to encrypt, TAC-I is the input file, which is the proof of concept.txt, and then TAC-k. Do I need an output file? I guess I can just do it to an output file anyway, it doesn't really matter. So TAC-o, we're just going to do output.txt. No output was given to your argument. Why are you trifling? Am I forgetting something, or is my code just broken? Okay, actually, I genuinely don't know why the thing is not working. Hold on. Because we tested it like 2 weeks ago, and it was working perfectly fine. No value was given to... What argument are you talking about? TAC-e is to encrypt. TAC-I Tech K's hello. All right. So the code is geeking right now. I guess we need to check out the main.py file and see what's going on. So if it's tech v python 3 / visionare.py, we can go to the vigenere.cipher.py. And I forget how long this thing is. Oh, we have F. All right. So do we use tech F or tech I in this thing? Because that might be tech I. Yeah, that's what we're doing. So why is there an F here? All right, I for the input file. If it's I, okay. Was that like the only thing? If tech I is in arguments, get the argument. Oh yeah, when we literally read. Okay, hold up. Hold up. Did I fix it or? Ooh, did it work? Output.txt. Okay, we fixed it. We fixed it. Let's go. Literally just deleted the letter F and replaced it with an I. All right. So now we have this giant string of encrypted lorem ipsum. I also want to make it print that the code worked and it was outputted somewhere, but we'll fix that later. So let's drop this into this string right here, right? So now we have an encrypted lorem ipsum. So now it says SSCPA. Yeah. Sweet. All right. So what are we doing from here? Oh yeah, we need to actually run that. So let's see back into resources, Visionaire, and then we'll Python 3 our unknown key.py. And look at that. It's getting the sequence. Okay, so this is it working out, doing its thing, I'm assuming. Oh yeah, I have it print out the sequences, yeah. I might not have it do this. This was for testing, obviously. We're not gonna have it print all this stuff out. Worst comes to worst, I still have the original code that I can just reformat. All right, cool. So I actually did use a lot of key length is mostly likely 19th. Yala may. Okay. Okay. So first of all, we don't need to print all that now. Oh, wait. I think I broke the code. That's what I did. Yeah, I'm dumb. Hold up. Can we still? Yeah, okay. So let's go into the code that they did and actually works. All right, let's go into our output.txt. We're going to, okay, let's use this thing instead. We're going to go into PowerShell, and instead of doing the unknown key, we're going to do that. So we're going to decrypt. Okay, yeah, see, look. So the key length is most likely 5. The key is hello. And this is the text, right? So it actually does work. The problem is that it only works on, I guess, strings longer than a certain length. So it works. So what we need to do is, first of all, we're deleting our unknown key. This was something that doesn't work anymore. We're just, well, you know what? We're just going to restart. We're going to restart the unknown key. We're going to copy this. So literally all the progress we made last stream, forget it. Forget it. We're restarting. So this does work. We need to focus it so that way we can only get the parts that focus on decrypting. So this def encrypt right here, yeah, gone. Delete. All right. What else are we deleting? Do I need anything else in here? So the maximum key length guess is 20. We're going to fix this, right? We need to make sure that this is not like this, right? Oh, I forgot to put some music on. I'm sorry, guys. You just hear me boring talking. Actually, should I put music on? Because, like, last time I put music on, I did get copyright strike. But then I changed it to royalty free. But also, when I'm doing the stream highlights, might be kind of weird. I'll put some music on for y'all. I'll put some music on. All right, I'll consider. Where did you learn how to hack? Boy, are you lucky that I actually have a whole video about how I got into hacking. To answer your question shorthand though, I started off doing malware development. That was kind of like how I actually was thrown into it, quote unquote. Hold up, sorry, give me 2 seconds. All right, cool. Yeah, so how I got into hacking was basically originally through malware development. I joined some Discord server, and I asked them to how do I get into cybersecurity and stuff, and they pranked me saying to learn older languages like Visual Basic, DOS, that type of thing. So I learned them and learned how cool they are for malware development, and that's how I guess I got into it, and then from there I kind of expanded my knowledge into web hacking and cryptography. How could you learn? If that is part of the question as well. Honestly, there's so many resources online. I know TryHackMe has a whole curriculum on how to get into Linux and hacking and that type of thing. So that's definitely something you can check out as well. Word. All right. So notes, and then would say make this user input because we want this to be user input. Lucky me, I guess. I can drop the link to the video. Copy link address. There you go. You can check it out after the stream. All right, so what are we doing now? All right, yeah, so what are we working on? Getting rid of the input as well, because we already getting input. So if it equals to E, no. We're getting rid of this. So we're not doing that either. Do I need that loop right there? Cool. All right, let's get... tab, tab. Is that right? All right, cool. Do you know the key? So the answer is obviously going to be no. So we can just get rid of this as well. And then elif yes, else no. And then no. Okay. All right, so we can just say true for now. We're going to get rid of... Oh, okay. Oh, I see what they did. Okay. ASCII is equal to false. And then ASCII will be equal to true. So then we can just put ASCII in here. Hit enter. Oh, whoops. All right, there you go. So we can also throw this over by one as well. Cipher text unfiltered. All right, so yeah, this, no. We're just getting the string. Do we even use this? Okay. Why is it asking? Oh, wow, ask. Yeah, we don't need this. So we have whatever the string's going to be. All right, so we're making progress. And then the rest of this, so key equals get key. Okay, so let's get our, I'm literally just going to find all the spaces and replace them with nothing. Awesome. So Control A, copy, and then we are going to go, what are we working on? Unknown key. Sweet. So we're going to throw that into the string. Sweet. Cool. All right, what's next? All right, so key most likely. Okay, so they get the key, and then they just decrypt. Sweet, using the ciphertext and the key. So the key is equal to the get key. Okay, so we only need get key. We don't need decrypt because we're going to have our own decryption process that we're using somewhere. Where is it? There you go, decrypt. So we have the plain content, the key, and the print content. So this is like the plain text or the encrypted. So that's fine. The print content, how do we get that working again? What do we do here? So if print content, oh yeah, so this is if they're using a file, like file input or string input. Or output, that's the output. Sweet. All right, cool. So let's make sure the unknown key is still working. So instead of Visionaire.py, we're going to do the unknown key. All right. Oh, ASCII equals false, yeah. So can we just like parse this over? All right, and let's try this. Sweet, all right, cool. So the key length is most likely 5. The key is hello. Awesome. So this is all the stuff that we need, right? So now they have this decrypt. We're going to need to modify this so that way it can work within the decrypt. So is there like a specific way that they're doing it specific to oh, let's see with the output, right? It's all lowercase. Is the original, no, see? So it makes it all lowercase. So it does mess with the format, which is fine. But if you're doing like, I don't know, like Capture the Flag, it might mess with it. So I could try to fix the formatting within it as well. All right. So I guess another thing we need to focus on as well is that although this does work with only on strings larger, I like to see if there's a way we can incorporate I don't know, some sort of detection to see if there's like a smaller string, we can just multiply the string into a bigger version of the string that's just repeating over and over again. And then, oh, would that mess with the encryption method? I guess we can just try, there's no harm in trying. So, cool. So from what it seems like, yeah, all right, cool. So what it seems like, this is just getting, I always forgot what I'm like, always forget what I'm trying to say. It's fine, whatever. Cool. What's up, Adam? How you doing? All right, so do we use this at any point within the code? We use it in get key length. Do we use get key length within the code? Okay, we do. So we'll keep both of those. Sweet. Is there anything that we can get rid of? So that's used, right? Get key length is used. Frequency analysis. Whoop. Frequency analysis. That's in the get key, and we use the get key. Do we use that? All right. All right, cool. So everything else we can keep. We can get rid of this and guess use the one we're already using. Cool. So let's try to incorporate this and see if we can get something working, right? So we'll get the Caesar cipher and we'll move the unknown pi to this side. Cool. And then we can close this. So let's close this and get to work. More water. Cool. So we need a function in our Caesar. Okay, we can get rid of this. We don't need this. We don't need this. We don't need this. Yeah, so this is all we need now. This is kind of hard to read, so I'm going to just bring this back over here. And let's get to work. So we have the decrypt Visionaire section, which we're going to use. And then, all right, so I guess I need a good name for this function because we're basically getting the Visionaire without, I guess, I'm always forgetting what I'm trying to say. Okay, I'm gonna just restart. This is why I don't like streaming, dude. Because no, I like streaming, but I don't like how easy it is just mess up and then you're just it's just on there. You can't edit it or anything. There's no like second tries. But what's we're trying to say? So, all right. So now what we're trying to do is get our new modified file, right? The functions in here and such, into our Visionaire Cipher. Cool. Let's do it. All right. So we need a new function. That's the main code. We need to do it like right before the command line interface. Oh no, we have a parse. Okay, so right up here. Yeah. So we will do, I guess, decrypts Vigenere with unknown key. Man's got a fresh cut. Yeah. Yeah. I'm gonna let it grow back out though. All right, so we're going to basically take that main function. So I literally called, we'll literally just call the function unknown key at this point, you know, def unknown key. All right, so in order to get this working, we're going to need the same thing that you need to decrypt, I guess, right? So the plain content, we don't have a key, and then the print content, right? So plain content. My kite has not been showing up, and I don't know why. No extensions found? Yo, what happened to kite? Kite, are you good? All right. Enable. Enabled? Are you sure it is enabled? All right, and then we're going to need our print. Isn't it like print CNT? That's how I did it, right? Yeah. Sweet. All right, we'll pass for now while we're figuring this out. Was that kite? Can I just do like a print? I don't know. All right, I have no idea if kite's actually working or not, so hopefully it is. Cool. So, yeah, close that. Cool. All right. I have to give this guy some credit in the README for sure, because this guy helped me out a lot. I think it was you, Adam, who helped me out with the with getting this working. So I appreciate that. Cool. Okay, we're not going to cut it out because we'll keep the file working. So instead of ciphertext unfiltered, we're literally just going to use the plain content. Awesome, sweet. So now we have to incorporate all these other functions. This code's going to be so disgusting because I'm going to have to like reformat it all. Honestly, at this point, all right, this is what we're doing. Sweet. Yeah, we're going to fix it, obviously. This is so bad. This is like one of the worst coding practices you can do. So don't be like me. How long is this file now? 300 lines. Cool. So we're going to have to throw basically all of this up to the top of the page. All right, let's make like a doc string here, just so we can identify, I guess, like unknown key processes. Awesome. So let's go straight to the top. Cool. So we have our symbols. Cool. So what my goal is to, instead of decrypt, can we use the decrypt Visionaire? Is that a function we have? There you go. All right. I don't know why it's trifling so much. Cool. What are we doing now? So we got all of this imported, the ciphertext key, and we're also going to need the print. All right, yeah, kite is not working for me right now. If anyone knows what's trifling or what's going on, let me know. So from here on down, it should actually work. The only concern is, all right, so now we have to incorporate this into the actual code. So where's the parser at? So if we don't have the key, we're going to use the tag U, right? We can use a U for unknown key. So we'll go through here. Oh, let's get rid of unknown key. Yeah. Okay, we got rid of that line. I forgot we did that. My bad. My bad. Okay. So let's go through here and we'll add the unknown key. Unknown key. So we'll just say processing options, right? So we'll add an if opt is equal to our tag U. Then we can add it to our arg dictionary. So we can do argdict is equal to our tag U. And then we'll have it be equal to the argument that we're, I guess, retaining. And that should be it on that front. Then we still have to do, so key equals arguments dot get tag K. Oh, should that be a ciphering option? Yeah. All right. New plan. The tag U is a ciphering option instead of an additional argument. Unknown or decrypt unknown key, and then here you say known key. All right, sweet. So if we go all the way to like the bottom of the code, Awesome, sweet, sweet, sweet. So we can just say decrypts with unknown key. So if our ciphering process is equal to tac u, decrypt. Oh, I just have to use the unknown key, and then our inputted contents key, and then our print content. Oh, wait. The whole point of this is that we don't have the key. Why am I adding the key in there? Print content. All right, sweet. So is that it? Is that all we need to do, or do we need to incorporate that into here? If ciphering option. Oh, okay. No, we just run the Vigenere Cipher with those arguments. Sweet. All right. Let's try to run this. CD out of here, Python 3 main.py. All right, so we got the tech. You know what? There you go. So we have a tech v for the Visionaire, the tech u. Our tech I is going to be our proof of concept.txt. And then I guess we can just have it output. Well, there's no K, right? Let's go! All right, why did it add this little thing? Key AAA, and then plain text is none. So it decrypted it, and key length is mostly 5. All right, let's rerun this. Maybe I hit something. So it's not getting the key. And it's not... So it got the key length. Okay. So we got... Where are we doing the actual unknown key? Sweet. Why is this not working? So key is most likely... So where's the get key? Oh, come on, y'all. Come on. Why is this not working? Why is this not working? All right, I need to think this out. All right, let me think. So it's running the Caesar ciphers.py. Wait, what's the command we're running? So we got the min.py, we have the tac v and the tac u, which is going to run the unknown. Then we have a tac I for the proof of concept.txt. It might not be looping. All right, okay, that's the CLI, that's the parser, here you go. So if I try it with this, I could actually just control F5 this one probably. Decrypt is not defined, okay. Cool. Let's try this again. So most likely 5, hello, plain text. Sweet. So what's not working? We don't have to worry about the plain text because we don't really need to worry about printing it. What we need to worry about is the key. The key needs to be shown because that's what goes through. But if the key went through and printed this, right? What's the file we're inputting? Okay, what if I input the output.txt file? See if it's actually working. Yeah, it's not working. It got the key though. It might be the decrypt Visionaire. But that shouldn't mess with it. You're just printing the form, like the key. And that we don't need the... All right, yeah, so I understand. Oh, is that what it is? All right, yeah, we don't need the plain text as the decrypt Visionaire is taking care of that for us. We just need the key. Oh, whoops. There you go. So let's try. All right, what's going on? Okay. So if we throw in our proof of concept.txt. All right, what does the proof of concept.txt have in it, right? Okay, that's the plain text one. We need to throw in the output one because that's the one that's encrypted. So let's, what? Okay, wrong button. So we need to throw in the output.txt because that's the one that's encrypted. My bad. So output.txt. Okay, so the key is hello. That's the decrypted content. Sweet. So the only thing I would like to do is just print this out beforehand. But it seems like it was trifling when we were doing that. Yeah. Key. All right. Why is it erroring? Does anyone know? Like, and sorry about the construction noises going on. I'm sure you guys can hear that. Sweet. All right. Why is this trifling so much? Oh, okay. That was it? It was just an indent error? Seriously? All right. We can close this. So now we actually have that working. Cool. So now we're just gonna have to clean up the code. All right. So if we, yeah. So let's Control L, and all we're doing here is saying we want to use the Vigenere Cipher. We have an unknown key, and we're inputting the output.txt file, which is just the encrypted Visionaire Cipher. If we check it out, output.txt is just encrypted text. So if we were to run this, hello? All right, I don't know why this is trifling so much. There you go. So the key length is most likely 5. Key is hello, and then the decrypted content. Sweet. So if we were to do a tech O and save it to deck.txt for decrypted, if we were to do that, all right, sweet. And then we go to the DEC or decrypted, and there is lorem ipsum. So the only problem is that, well, I guess that's like the file that the format the output.txt was in. The only problem is that any characters that were originally lowercase or uppercase are now lowercase, but it does work, which I'm very happy about. So now it's time to start incorporating, first of all, cleaning up the code, but second of all, incorporating the ability to decrypt shorter keys, right? Because if we have like a flag and we don't know the length of it, it would be super cool if we could just have it extend the length, right? So all right, so let's go in here. Unknown key, right? So if the plain content is shorter than a certain length, it will create the ciphertext into this, right? So if the plain content is less than or is greater than, let's say, what's the minimum length this has to be in? How many characters are in this? How do you check that again? Kite unsupported. You guys see that at the bottom? All right. So line 1 and column 1. If we go, all right, so there's 1,370 characters in this, right? Yeah. Whoa, whoops. So I honestly don't know. All right. I just need like the first 300. How much? What characters is this? 450. All right, that's better. All right, so if we do like 300. All right, perfect. 300. Control Shift down. Sweet. Oh, I'm doing this on the wrong file. Oh my gosh. Seriously? Oh, that's annoying. That's on the wrong file. Output.txt. All right, we're going straight to like here. That's 521. All right, we'll start from 500. Cool. Cool, sorry. I'm trying to figure out how I can do this. Awesome, perfect. So these are the first 500 characters. I'm trying to see the point of where it doesn't work, right? So let's not have the output file, so it's printed to the screen. Where did we do that? It's Visionaire. Let's comment this line out. So it does work, lorem ipsum at 500 characters. So if we were to delete another, I guess 100 characters, so let's go in the middle here. All right, yeah, so if we were to delete 1, 2, 3, 4, there you go. Another couple characters, so that's 200 characters, right? If we ran this, it still figures it out. So what's like the limit on this? Can I just do like, tag Visionaire E to encrypt? We'll do a text of, let's make up a flag, CCS, and then flag is cool. Perfect. And then the tag K of, let's say world. No, there was no value. What did I forget? Tag V, E to encrypt, tag K, and the text. It's always something. It's always something. 2 steps forward, 1 step back. Excuse me. It doesn't really matter, because at this point, we could literally just go to like Vigenere Cipher. I'll fix it later for the record. I just need a actual working one so I can alright, so we'll do CCS flag is cool. That's like a hypothetical flag, right? And then if we were to encode it with a key of world. All right, so this is what we would get, right? If we were to, all right, so instead of attack I, we're going to do attack T, and then this. Okay, so clearly is having trouble with the tag T. It might be the curly braces. Float division by 0. What on earth is going on, dude? Did the code break? Or did, oh, it can't work on something that small. I forgot. That's literally the error we were having literally the entire last stream. So if we took this, right? So if we were to add this together, let's say up to the length of 200, could we decrypt the content is, yeah. So it doesn't work with the 200 length. If we were to get to 300, could it figure it out? Okay. So Control H, find all opening brackets, Control Enter. If I have any closing curly braces, Control Enter. All right, sweet. All right, so yeah, I can't figure that out at 300. All right, can we... So if we boost it up to like near 500, and then... All right, yeah, it is not figuring this out. That's too random. There's not enough. Okay, so what I think we're going to do is kind of keep that functionality there. I guess first up we need to clean this code because holy, it went from like 100 to near 400 lines. So I guess we'll just start from the top. So auto decrypt, tech A. No, we just did tech U is fine. Hard brute. Oh, the pick range, right? So the max key length by default is 20. Should we have to... Should I incorporate like a key length and then have it like default be 20? I guess we could just redefine it. Where's the parser? All right, we can do a L for the length of the key. All right, and then we can do key length. And then we need to get rid of... I know you guys probably can't see what I'm doing, but it's fine. Cool. So we don't need this U anymore because we're not using it in here. So this is actually one of the options, though, or one of the processing options. So if our option is equal to attack L, then we need to have it be quote unquote appended to or added to our dictionary, right? So we can have that tech L and then arg. Cool. So here we can just do a checks if key length was specified. All right, and then we can do if, and then our tech L is in our arguments. And then we can just say, all right, so at the top here, we do have a max key length. Guess, and it's in all caps as if it were a constant, but it's no longer a constant. So we're just going to say maximum key so Control Alt Enter. All right, perfect. So we can have our maximum key length, have that be equal to the arguments. I have no idea why kite is not working right now. Whoops. Did I do something? What did I do? I did something. Oh, formatter? Oh, that's what I did? Whoops. Maximum key length equals arguments. Okay, so I need to convert it to an integer. Sweet. So if we go through here and check out our maximum key length, we use it towards the top. Okay, and then in our Visionaire Cipher, the help menu, we need to add, all right, we'll have it be after, up towards the bottom. So we can say the tech L, maximum key length. So this is just a okay, wait, in our Caesar cipher, we add required one. How do we do that? So tech B, there's something like add keys to a star not required for brute forcing. And then, okay, that's how we do. Okay. So now what we need to do is have our tech L max length. So this is equal to the maximum guess length for decrypting for unknown key decryption. Min.pi, tac u, and then our tac I. Oh, main.py, tac v, tac u, tac I, file.txt. And then we're also going to have to add the zero division error. So we'll say try, and the except will be the letting you know that you can't decrypt with that view. So main.py, tac v, tac u, tac I, file.txt. And that's it, really. Sweet. Cool. So if we go back to, we can close this. So this is working in coherence with the Visionaire. Sweet. All right, we can get rid of this line. So this would be second argument, which is the ciphering process. Then we have our Visionaire Cipher. And this should also, oh no, it says in here. All right, cool. So let's start from the top, make our way down, fixing all this. Document code, cleanup code, yeah. All right, we're getting rid of these to-dos. All right, let me give my man a shout out to whoever developed that script. Control B. All right. Drew P41. Appreciate you, man. So I'm gonna give this guy a shout out in the README. Thanks to Andrew Paul, I'll put some stuff in there later, but that's just to remind me to give him a shout out. And then I'll drop the GitHub thing. So we'll put this in the README. So we have the imports, then we have the banner, help menu, then letters for the encryption. So symbols that can't be processed through the cipher. Right, all right, so we made that user input now. We actually do need to test that user input stage to make sure it actually is working. So the encrypt Visionaire is good. Oh yeah, I think the format thing did something to all this, which is fine. All right, and then the decryption process looks good. Cool. Oh my gosh. All right. So we don't need to explain how this works. We just need to yeah, so let's actually start modifying the modified script. How do we go about doing this? So gets index through coincidence using index coincidence formula. All right, delete the capital letters because that's not. Oh yeah, so yeah, now I'm basically just cleaning up the code right now. Seeing if there's anything else that we can kind of work on and work through. Split cipher text into sequences based on the guess key length. Iterates through key sequences, or I guess possible. Oh yeah, and that needs to be a comment. Returns key length with highest average. All right. So we'll just try this, and if we get a division by zero, divide by zero error, whatever the error is called, then we can just have it be accounted for. And then returns the index of highest. So returns the most likely key length. Sweet. So if, best guess, whatever. Okay. So return the letter of the key that needs to be shifted by. All right, sweet. Okay. Where did I go? What? Okay, it just scrolled me up for whatever reason. So count the numbers of each letter in each sequence. All right, and then, cool. So space divide for an array. Now you can compare. Compare frequencies. All right, there you go. So append it all. Sweet. All right. So now this gets the key, right? So we can do this gets key. All right, and then, cool. All right, and then, I'm just trying to make the code a little bit cleaner because it's getting kind of crazy. So this decrypts with the T. All right, sweet. And then we're basically just decrypting Visionaire. Outputting key data. I guess, whoops. Calculating, right? Calculating the key data. Woo! Whoops. By the way, my light bulb died, like, up here. So now it's just, like, dark in here. So I just got the studio lights. So that's going to be kind of annoying for recording videos. But it's fine. I'll figure it out. Alright, then this is where we parse arguments, and awesome. So that should be it. I think we need to, first of all, try and accept. Cool. So we're going to do a try. So here we're basically just going to tries to get the key. All right, we're going to try, and we're going to have that accept 0 division error. Is that the error? Accept 0 division error. We'll just print okay, yeah, we're basically just going to drop this whole thing in here, and we'll go ahead and tab it over. Then we'll say, so we'll say if the plain text was too small, we'll print okay, so we can, so which one are we using? Are we using single or double? Because I'm trying to stay as close as I can to PEP 8, but I know I've been kind of lacking a little bit on that front. All right, so I'm using single quotes for this whole thing. So All right, that's also some stuff I'm gonna have to reformat in the Visionaire. We can actually delete the resource now. If we go to resources, we can delete. Sweet, cool. Okay, that looks good. Then we had to go down here. So yeah, this is all the new stuff. So I'll just basically have to. I feel like cleaning up code is like one of the more boring parts of coding. It's very important, but it's like boring. Like no one actually likes cleaning up their code. But it's going to make it a lot easier the further in we go, because it'll be easier to read and easier to understand what we're doing. And also easier for you guys to understand what I'm doing. Hopefully. Cool. All right, we can add this here. All right, sweet. So all we have to do now is, all right, yeah, so we're making these F strings. I don't know why we have this formatting. There you go. So in here, we would just do key underscore length. All right, and then this. All right, why is this still? Oh, sweet. All right, and then we can double delete. So this should be all up to date now. I guess we can Control L. So let's see. We'll move down a little bit. I'll move down just so you guys can see. Perfect. We'll do our Python 3 main.py, and then we'll do attack I, or actually no, we're doing the Vigenere Cipher. We'll do the attack U because we don't know the key, and then our input file is going to be, what's our input file? Is this encrypted or not? Is it? No. Oh, the output.txt file, right? Sweet. Yeah, we'll use the output.txt file. So we'll do output.txt, download it, run it. So key length is most likely 1. What happened? Didn't we get this working? What on earth? Oh my gosh. All right. Why is this not working? We just had it working, did we not? Oh my gosh, Jan. I would really like to be able to finish the Visionaire Cipher by the end of the stream, because it's been the 3rd stream and we're working on this. So is there anything of significance that I changed? that would allow this to not work. The only thing I did was add notation, like documentation, quote unquote. There's no reason, Jan. So our main.py, we have the Vigenere, so that's the tech v. Python 3 ciphers Vigenere.py, and then our arguments. Sorry guys, excuse me. Oh my gosh, that is so annoying. Sorry guys, give me 2 seconds. Alright, what can we do? What can we do? Runs main code. Alright, we have a problem. I'm not entirely sure of what this problem is, but I know it's there. This literally was just working and it's pissing me off. Why is this not working? All right. So if we go towards the bottom, we can print all right, yeah, so we can delete this. We won't need this. Whoops. Tries to get key. Is it the tech L that's missing with it? The plain text you entered was too small for this. So \n, please add a bigger file. Oh, it's not plain text, it's ciphertext. The ciphertext. Sweet. All right. And this is the error, right? The 0 division error. All right. Let's cd into our ciphers. So if I just do a Python 3 Vigenere Cipher. We do the tech E to the tech U. It's going to say we need to add more arguments, right? So we do the tech U, then we can add a tech I, which would be the dot dot slash output dot txt. Oh my gosh. What happened, yo? So it looks like it decrypted fine. So it's getting the key is the problem. So key length, we get key length ciphertext. If we go to this function, the get key length function. So for guess in the range of the maximum key length. Oh, that's the error. Maximum key length equals 20, but we'll just say max key length. So if I go literally all the way down here, let's delete this. And then let's go into our parser. Let's delete this. And then go into our options and delete, all right, cool. So if I go ahead and key length is most likely 1. That should be working. Guess get key length. So the max key length is 20. Sequence equals this. Okay. All right. We're going to go to the track. All right. I'm closing Obsidian. I'm not touching it right now. Let's go to our trash bin. Does anyone know how to find that trash bin? How do we find that? Isn't it like all right, view, show the sub icons, recycle bin. So let's search for the Visionaire. Yeah, so we're going to restore. Sweet. And then we are going to go back to view. Don't show the desktop icons anymore. All right, so we should have this back in our resources. Sweet. All right. And what I'm going to do, should I just like try to recopy this code and see? So let's copy this and see if we can literally just drop it back in here again as like a second attempt. So instead of max key length guess, we'll replace it with max key length. All right, and we're going to also go to the top here so that way I can find the variable I used, which is max underscore key underscore length. Control Alt Enter. And if we were to run this, it still doesn't work. It must be with something with how we're actually getting their content. Oh my gosh. Cool. Why is this not working? We can go over here. Yeah, I don't understand why this isn't working. It was working like literally a few minutes ago. If we tried the unknown key file, is this going to work? CD out of here into resources, Visionaire, Python 3 unknown key.py. Yeah, it works over there. Is having trouble with the plain content maybe? Could that be what it is? Oh my gosh. I must have done something. Let's go back to our Visionaire file. It doesn't make any sense though. So the unknown key works. Cool. So in this Visionaire, we're going to compare this section of the unknown key to this section. So we get the ciphertext. Then ciphertext join, whatever. Then we do the key length. Let's get key length. Then we get the key. We don't worry about plain text because we can just decrypt it. All right, so let's just compare these side by side until we notice any flaws. Can't index key, right? Those look about the same. Yep. All right, so that's fine. So there's the table. Then it iterates through the max key length, through those variables for the range. guess length. We do a 4J. And then the sequence plus equals, I see sum, if not AG, okay. Then we have the guesses, and then the averaging outs. All right, and then we have frequency analysis. That looks about right. All right. Cool. So then you subtract float, all this, and then those two values. And then you have your key equals empty string. Then for I in range, you do this, you do that. Then the key plus equals whatever, return the key. And then you have your unknown key. What on earth, Yon? That's a decrypt, we're not using that. So I literally just compared side by side all the code. And all right, so let's see if we can print the plain all right, let's print out the plain content. And then yeah, all right, so if we were to print this, oh, that's the unknown key, whoops. Cannot find path. Oh, is that the error? Oh, is it the location of the file that's giving the trouble? No, because oh, Python 3 Visionaire Cipher. Yes, that was running the wrong thing. No such file or directory. Where am I? Oh, I see the problem. So cd out Python 3 main.py. Then we'll have the tag v, the tag u, the tag I, which will be the output.txt, and then that should be it. So that's the text, so it's getting it. Why does it think the key is most likely 1? Oh my gosh, y'all. I'm using the wrong file. That's just the key. That's just the flag over and over again. Oh my gosh, I have been wasting my time for the past freaking half hour. I think. Oh my gosh. If this works, I'm gonna be so pissed. Python main.py tag v tag encrypt will encrypt our input file, which is our proof of concept. .txt. We use the tag k of the word world. Oh, whoops. Yeah, let's tech A, the word world, and then tech O to our out.txt. Awesome. And then if we were to check out our out.txt, there you go, the out.txt, yeah, it's encrypted. So let's go ahead and then just do what we were doing here with our out.txt. Look at that key length. Oh my gosh. Guys, I have literally been wasting my time for the past 30 minutes. It worked. I was just using the wrong file. That pisses me off so much. Yeah, alright, delete this print statement. Alright, well, I'm done with the Visionaire Cipher, finally. I guess we need to do one more thing to show that, yeah, okay, first of all, that does fry. I've been wasting my time this whole time, because we got the code to work. Because we do this, it should just say Visionaire Cipher, key, world. Okay, well, let me, I guess, format it like that, just so that way it looks a little bit prettier. So if we do this, cool. So if we do end up printing, all right, so where's the decrypt? So our decrypt Visionaire, where we do this, we can just print. All right, then we can just say output written to output file. Output written to file successfully. Copy. All right, and that's the decrypt. So this is all right, there you go. Sweet. All right, so that's for the Visionaire Cipher. Then we need to go to Caesar Cipher and incorporate this stuff in as well, and then we should be done for today. So that's the decrypts. So decryption SS, which means this is the encryption, where throw this in here. All right, so got that. Brute forces contents. Sweet. All right, there you go. So Caesar Cipher has been updated. Visionaire Cipher has been updated. And we're going to go through here. And the tech L is something for another day. We can go back to it in the future, but for right now, I think that should be good. So let's actually try it out, guys. I'll clear my terminal and I'll just go down a few so you guys can see. All right. So we got the Python 3 and then our main.py. If we run it, we have our updated version of the Codex. So we have the Codex, project one-liners, right? So there's the tag C for the Caesar Cipher and the tag V for Visionaire. The Caesar Cipher, we have these arguments here, and for the Visionaire that we've literally just finished, hopefully, this is the syntax for that. So we can do a Python 3 main.py. We'll do the tag V for the Visionaire, and then we'll do the tag U for the unknown key. Then we will attach a file of, let's say, the out.txt because this is encrypted. So we'll do out.txt. And if we run this, it should figure out what key we used to encrypt it, which is world, the length of that key, and the decrypted content. Wow, that's awesome. That's awesome. That really is a cool feeling. Like, we had to get rid of a lot of this. Where's PowerShell? Explorer. There you go. Oh, whoops, that's not what I meant to do. There you go. So we can whip out the our Explorer. Keep the readme.md. Alright, so we delete these .txt files, this text file. In our resources, delete that. Let's get Obsidian ciphers is good. Sweet. And then templates should be good. We never touched that. The license. Sweet. All right. So we can clear this and we can throw it up to Git, right? So Git, pull anything that we have on there. Git, add all. Actually, now that I think about it, the Codex project, I'll just say syntax. And then the last thing I want to do super quickly, now that I thought about it, was jump down to here. Most probable key, right? Sweet. And that's it. We can, oh, you know what's crazy? We can just do it through this thing right here. So we can just say added unknown key decryption. You can control enter it. And then we can sync it. So if I go onto GitHub, we're still zoomed in, so I'll zoom out real quick. We go to our repositories, Codex project, and you can see working on Visionaire unknown key. Yeah, there you go. So add unknown key. Yeah, so it's updated. Yeah, added unknown key decryption. So it's on the GitHub now, and everything should be up to date. That hurt my brain so much. Let me go back to my face. Hopefully this stream wasn't, killing you guys the way it killed me. Hopefully it was something you kind of enjoyed, and I'm gonna end the stream here so I can kind of decompress and record the video for Monday, which should be pretty cool. It's a USB rubber ducky payload, and you probably already saw it on my GitHub already. I made it public. I always do that, just make them public. But you can check out the GitHub, you can check out the code I just uploaded, and we will get back to work on this either next Friday or later in the week. We'll see. But yeah, so make sure to leave a like, subscribe, and do the whole YouTube algorithm thing, and I'll see you guys in the next one. So stay happy, stay positive, and as always, happy hacking.